Hello guys, welcome once more to class online. My name is Tutodami, and in this edition we shall be looking at Jamb Physics 2014 question number 31 to number 35. And in this edition we shall be dealing with the aspect of physics that has to do with telescope and with capacitance calculation, and we shall be simplifying it in a way that you shall understand. Now don't forget that if you like this video or if you learn something from this video, click on like button. We have more content to send to you that will better clarify physics to you. And let's get to the question number 31. In a compound microscope, the objective and eyepiece focal lengths are what? Are they long? Are they short? Or are they the same, or are they at infinity? Now, what do you think? Now, if you've ever been taught, you know the word microscope, right? A compound microscope, right? Now, microscope is used to make tiny things to become large, right? It is used to magnify tiny things. Now, but it has two lengths. The objective lens, that's the lens that is closer to the thing we are looking at, and then we have the eyepiece lens. That's the lens closer to the eye. Okay, so if you look at a microscope, the one closer to your eye is your eyepiece lens. The one closer to the object is the objective lens. Now, are the two lenses, are they long, or are they short, or are they the same, or are they at infinity? Now, actually, at infinity, I would have felt we should not be among the options. But let's take a look at it now. Now, here it is. Now, you can see that the size of the eyepiece lens and the size of the objective lens are actually the same. So, a compound microscope consists of two lenses, gives greater magnification than a single lens. Okay, so the objective lens has a shorter focal length. The ocular lens or the eyepiece lens, the ocular lens or the eyepiece lens has a focal length of a few centimeters. So both lenses have the same size. The eyepiece lens and the objective lens, right? They are actually the same length, right? Now that means this is as tall as this. So equally, one is not bigger than the other. They are actually the same. So the answer to that question is simply they are the same. 32. When a telescope is in normal use, the final image is at what? Now, for a normal telescope, now this is a telescope. A telescope is used to see very distant objects. Now, for a telescope, as we use telescope, some people use telescope to look at the galaxy or look at the other planets around the Earth with a telescope, right? Now, but the final image, that's if I'm looking at the moon with a telescope, the final image of the moon that I will see in the telescope, where is it from? Is it at the focus, or the radius of curvature, on the near point, or at infinity? Now here it is. Now look at, this is my eye here. This place is my eye. You can see my eye here. This is my eye here. This is the eye of somebody. His name is Mr. Dami. That's me. Now I'm looking at the moon now. Now as I'm looking at the moon, the first lens. Now for a telescope, you can see that the lenses are not the same. Unlike a microscope, one is bigger because you are looking at an object that is extremely far. So the objective lens is bigger and the eyepiece lens is smaller. But look at this now. The moon you are looking at is at infinity. So you have to bring it from infinity to nearer. That's nearer to you. And that is why we have this large lens. Now, as it's bringing it in, now the image is formed. Now, the final image of the moon that I will see is formed where? Now, as it brings it in, you can see it forms here. But I am looking at it with this smaller lens. So when I'm looking at it, the image I will be seeing is also formed at infinity within the microscope. The telescope. So the telescope brings it from what? Infinity, and forms it at what? Infinity. So the final image at infinity, when I'm looking at it, I'll be looking at it from infinity again. So it is from infinity formed at infinity. And you know, infinity means endlessness. That's an extremely far distance. So if you are breaking it from a far distance, it is also forming it at a far distance so that I can also see. So that just if you are looking at the moon, it's not like you will really see the moon from the telescope like you will really see the moon the way you will see it when you are on the moon. You will still see it. It will just be bigger. It will just be bigger, but it will not be as clear. But it will only be bigger. Okay, that is what you are saying is at infinity. But because of the lens, The function of the lens is not to make it look like you are looking at it in your front. The function of the lens is to make it bigger, okay, so that you can see it, okay, but the image remains at infinity. So that's it. So the object came in here and formed an image, but even the image too is formed at infinity. So it is just a magnification. It is not really to bring it close. It is just a magnification. And then so the final image will be formed also at infinity, just like the object is at infinity. The final image that you see will also be at infinity, and that is the answer. When a negative charge rod is brought near the cap of a charged gold leaf electroscope which has positive charge, okay, the leaf dash. Now we've heard about when you on the topic electrostasis or static electricity, you've learned about gold leaf electroscope. That is a machine that is used to detect charge, if the charge is positive or negative, or if a body is charged. Now the gold leaf electroscope, now if the gold leaf had been negatively charged, I'll come again. If the gold leaf had been negatively charged, the gold leaf indicates charges by closing or opening. That means it is by diffraction. It is by opening or closing that the gold leaf indicates charges. Now, but if the gold leaf itself is negative, if you bring a negative charge near a negative gold leaf, it will open. Now, if the charge is the opposite of the charge of the gold leaf, so if the gold leaf is positive and you bring a positive charge near it, it will diffract or open. But if you bring an opposite charge near it, if the gold leaf is negative and you bring a positive charge near it, it won't open, it will close. And that's the way it functions. Now, this is a negative charge rod, coming near the cap of a charged gold leaf which has a positive charge. You are bringing a negative charge rod near a positive gold leaf. It will not open, it will collapse. That means it will close. What I mean by that, I think I have a picture here. Now, if this is a gold leaf, okay, now this is a gold leaf, right? But the gold leaf is negative, right? Now, if you now bring like this one is positive gold leaf, but you are bringing a negative rod near it. What happened to the gold leaf? The gold leaf did not open. The gold leaf was collapsed because the charges are not the same, and that is just it. So by bringing a negative or an opposite charge near a gold leaf that has an opposite charge, by bringing an opposite rod near a gold leaf that have an opposite charge, if the charges are not the same, in simple terms, it will collapse or close. But if the charges are the same, it will diverge or open. And that is it. So the answer to that question, since the rod is negative and the gold leaf is positive, they are not friends, right? So it will collapse, and that is the answer. It will collapse. 34. What charge is stored in a 0.4 farad if capacitor when that should be of capacitor when a 10-volt supply is connected across it? Now this is a question between, it's asking for charge, it gave you capacitance in farad, and it gave you voltage in volts. Now what is the relationship? What formula combines charge, capacitance, and voltage? Do you have any idea? Now actually the answer is very simple, and here is the answer. Now Q equals CV. I always call this formula, I memorize this formula with the word CV. When you say when you are looking for a job, you look for CV. So you have to present your CV, right? So the formula that binds charge and capacitance and voltage is Q equals CV, where Q is my charge, C is capacitance, and V is voltage. Now, in the question we say what charge, is saying what charge. So simply put, is stored in a 0.1 farad. That's in a 0.1 farad capacitor. Okay, that should be 0.1 farad capacitor. Okay, now when a 10-volt supply, now the capacitance is therefore, that's my C is 0.1 and my voltage is 10 volts. So it is just simply put 0.1 times 10, and the answer is just Q equals 0.1 times 10 is simply 1, and that's my answer. The answer is 1 coulomb. This C is capacitance. but charge is measured in coulombs. So the answer is 1 coulomb. Not, please note, differentiate this C from this C. This answer is 1 coulomb. Why this one is, I represent it with what? Capacitance. So the answer is just 1 coulomb. So multiplying the capacitance and the voltage will give you the charge, and that is just a 1 coulomb. Now number 35, the last one for this video. Calculate the effective capacitance of a circuit above. Now you have this circuit. You can see that the circuit has 2 series, that means they are on a straight line, and 3 parallel. This is parallel. They are all capacitances. They are all in farad. They are actually microfarad. This one that looks like U is called micro. So this is microfarad, 2 microfarad, 2 microfarad, 2 microfarad in parallel. Okay, then 2 microfarad and 3 microfarad in series. So now you are finding the total or the effective capacitance. How do you do that? Now what you have to do is very simple. Just mix up all the parallels. That's this. You have to begin from parallel, and if you are calculating the total parallel capacitance, you will need to plus them up. That will become total parallel is 2 plus 2 plus 2, which is 6 farad. Then now it is now 6 farad is now standing straight as the total. So everything is now in series. This is series. This one, the total, I've mixed up all the parallel, is now giving me 6 microfarad in series, right? Then I have 2 farad. So I have all this now, all is now in series because I have removed all the parallel. I've summarized all the parallel. I've formed them into series. That will now give me 3, 6, 2. And if you are finding capacitance in series, the formula to use is not just to add. You have to do 1 over the total capacitance in series equals 1 over each of them. 1 over 2 plus 1 over 6 plus 1 over 3. And that will give me 1 over total capacitance equals 2, 6, and 3. The LCM is 6. And that's 6. Then divide. 2 divided 6 is 3. 3 times 1 is 3. 3 divided 6 is 1. 1 times 1 is 1. 3 divided 6 is 2. 2 times 1 is 2. And that will give me 6 over 6. So that is it. Then if you break down 6 over 6, you have 1 over 1. So the capacitance total, if 1 cancel 1, I'll have my capacitance total as 1 microfarad. And that is my answer. The answer is 1 microfarad. And that brings us to the end of this video. Don't forget that if you learn something from this series, click on the like button. We have more content to send to you that will better help you understand things. Until we see again, guys, take care of yourself and bye for now.